Hi students, now we are going to derive a very important equation in the topic of optics, that is mirror equation, considering a concave mirror. Okay, so this topic right from your secondary school days you must have heard this equation, isn't it? What is mirror equation? It is the relationship between the object distance u, image distance v, and the focal length f. And you must be remembering that 1 by u plus 1 by v is equal to 1 by f. It is the same for both the concave mirror as well as the convex mirror. Okay children, now let us derive this equation. So for this I have considered a section of a portion of a spherical mirror, that is XY. It is concave towards the left. So XY is having a large radius of curvature, so better you always practice drawing it slightly flat and slightly curved, so that this portion DP is almost straight and perpendicular to the principal axis. Have a practice of considering DP, okay, as a vertical line. You see, this is the principal axis and P is the pole of the reflecting surface, pole of the mirror. F is the principal focus and C is the center of curvature. So I have considered an object AB. This type of object which is represented by a vertical line which is a straight line is called linear object. It is called as linear object. So always object is placed above the principal axis, and depending upon what type of image, whether virtual image or erect image, okay, so real image or virtual image, depending upon what image is formed, the image may be either above the principal axis or below the principal axis. Okay, I have taken a straight and linear object AB which is placed above the principal axis at a point beyond the center of curvature C. You can see here it is kept beyond C, and we have already heard that the object is kept beyond C means image must be found between F and C, isn't it? So in such a way the diagram also is drawn. So for the image formation always at least two incident rays and two reflected rays are required. So you draw only two incident rays and two reflected rays in the examination also, not more than that. It will confuse your derivation. So now what type of incident rays I have considered? You see here one incident ray, you can see BD, isn't it? It is traveling parallel to the principal axis. When a ray of light parallel to the principal axis is incident on a mirror, then the reflected ray of light must travel through the principal focus. Can you see here? BD is the incident ray parallel to the principal axis, and DF, okay, this is the reflected ray. So this is passing through the principal focus. Okay, now another ray BP I have taken traveling along the direction BP. That means that second incident ray is falling at which point? At the pole itself, isn't it? So from the pole along the principal axis only the normal is traveling. Therefore this angle, okay, this angle made by the incident ray with the pole must be equal to the angle made by the reflected ray with the principal axis at pole. Therefore at the same angle of incidence it will be reflected. Okay, now you see that the two reflected rays are meeting at one point. At that point only the image must be formed, isn't it? So the point of intersection of the two reflected rays I have noted. From there a perpendicular is drawn to the principal axis and it is denoted as A dash B dash. Okay, so A dash B dash is the image. AB is the object. Okay, the object is kept above the principal axis and the image is found below the principal axis. So it is down. It is inverted image. And you look at the size of the image which is smaller than the object. So it is a diminished image. So this is a image. Image is formed in front of the mirror. So what is the name of such image which is found on the same side of the object? It is a real image. It is a real image and it is a inverted image. As I already told you, you have to draw the portion DP linear, okay? And it is perpendicular to the principal axis, so that I can represent this angle DPF as a right angle. Now, you consider two pairs of triangles. The triangle ABP and A', So I will write triangle, okay, triangle ABP, which is a right angle at A, okay, and another triangle is A', okay, so A', B', So these two triangles only you have to see now. In these two triangles, okay, you see that this angle of incidence is equal to the angle of reflection, and this angle A, I mean this angle is right angled. So this also is right angled. So this angle 1 is equal to angle 2, and right angles are also equal, means naturally the third angle must also be the same, is it not? So these two triangles ABP and A', are similar triangles. They are similar triangles. All the three angles are equal, okay? Therefore, by the rules of similar triangles, the ratio of any two proportional sides must be a constant in both the triangles. So I am going to consider now A', okay? The side A', B' in this triangle. A similar side here is AB. So A', B' divided by AB. This must be equal to the ratio of the other set of two sides, proportional sides. So for that I will take P to A'. So P to A' distance divided by P to A. So this distance PA, and this is equation 1. Okay. Similarly, another set of triangles I am going to consider. So for that you look at this angle, okay? This angle is vertically opposite angle. Can you see these two angles? So the principal axis and the reflected ray DF both are meeting at this point, intersecting at this point F. So these two angles are equal because they are vertically opposite angles. So these two triangles I am going to now consider. So the triangle F A', B' or A', B' F. I will take the triangle A', B' F, this small right angled triangle, and the other triangle is DPF, okay? So these two triangles, I am going to show that they are similar. Why these two triangles are similar? I have already told you that these two angles are equal. Understand? Because vertically opposite angles. Then this is right angled here. This also is right angled equal to 90 degree. Naturally the third angle must be same or not. Okay. So this also is what all the three angles of these two triangles are equal, and hence these two are similar. Okay. Again, what we are going to take the rules of similar triangles, ratio of proportional sides I am going to take, is it not? So I take this A', B' first. Proportional side is what? DP. But always you express in terms of pole first. So PD. So A', B' by PD. So the ratio of the sides A', B' divided by PD. And this is equal to the proportional sides F A'. So this is F A' divided by PF, this proportional side, okay, that is the PF, and This is now equation 2. Okay. Now in this picture, the height of the object is AB. Is it not? Height of the object is equal to AB and it is equal to the height PD, because this incident ray BD is parallel to the principal axis. These two sides AB and PD must be equal. AB is also equal to PD. Instead of PD in this equation, I can also substitute AB. So the second equation I am rewriting, okay, since PD is also equal to AB. So left hand side of equation 2 becomes A dash B dash divided by AB is equal to F A dash divided by PF, and this is equation 3. Okay. Now you observe equation 1 and equation 3, they have same LHS. Is it not? Left hand side of equation 1 and 3 are same, A dash B dash by AB. Here also A dash B dash by AB. So I am going to compare equations 1 and 3. Okay. So comparing equations 1 and 3. This is the step. So P A dash by PA. P A dash divided by PA is equal to F A dash by PF. F A dash divided by PF. In this diagram, F A dash is a small distance coming in the middle, is it not? So this F A dash also can be written as P to A dash minus P to F. Is it not? P A dash minus P F. In that form I am going to write. So this is P to A dash minus PF divided by PF. Okay, divided by PF. So P A dash by PA is equal to P A dash minus PF divided by PF. So this I will take as equation 4. Now by the sign conventions for a mirror we have studied all distances like the object distance, image distance, radius of curvature, focal length, all should be measured from the pole of the mirror. Okay. Now I am going to use the sign conventions. You see here, from sign conventions. What is P to A? First of all, what is P to A? From the pole to the object. This is the object distance, is it not? So P to A, P to A is the object distance. I will write in words so that you will understand clearly. So this is the object distance. Object distance is represented by the symbol small u. But in which direction you are traveling to measure this object distance? You see, from the pole to the object you are going towards the left. But light is traveling towards the right. Are you going opposite to the direction of the light? Then u must be what? Negative. So this is equal to minus u. So PA is equal to minus u. Okay children, now what is P to A dash? P A dash, where is A dash? It is here. So P to A dash. So this is the image, is it not? So P to A dash, this distance P A dash, okay, P A dash must be called as what? Image distance. So whether it is positive or negative, let us see. So P A dash. From the pole up to A dash, once again we are traveling in a direction opposite to that of the direction of light. Therefore, it is minus V. Understand that? So object distance is minus U and image distance is what? Minus V. In a similar way, P to F. Okay, P to F. P to F is called focal length of the mirror. Focal length of a concave mirror is negative. Is it not? Already you must have studied in 10th standard. So from the pole to focus also you are traveling in a direction opposite to the direction of light. Therefore, this also is represented as negative. So minus of F. So PA we have written, PA dash we have written, PF also we have written. Again in the same notation only it is coming. So all these sign conventions are applied in the equation 4. So rewriting equation 4. Okay children. So rewriting equation 4 by applying the sign convention. Okay children, you tell me, in place of PA dash shall I substitute minus of V in the numerator? Minus of V divided by PA. In place of PA it is minus of U, and this is equal to PA dash minus PF. PA dash. So PA dash is minus V. Minus V. Again there is a minus sign. Then PF. PF itself is again minus. So this is a minus F. Systematically you substitute, no error will come. Understand that? So as it is I am substituting. So this is minus F whole divided by PF. PF is what? Minus F. So this minus and minus get cancelled. So this will be equal to what? V by U. And here I will take minus as a common factor. So this is once again written as minus V. So this is minus V. Minus of minus is plus F divided by what? Minus F. So I take on the numerator, this is a minus, I will take as a common factor. So this is a minus of V. Understand? And here minus of F whole divided by minus of F. So that once again if you cancel these negative signs, I can rewrite the equation like this. Or P by U is equal to V minus F by F. So this is V minus F divided by F. Or V by U is equal to V by F minus F by F. F by F is equal to 1. Is it not that? So this is V by U is equal to V by F minus 1. In this equation I will divide the numerators, okay, by V, dividing throughout by V. So dividing throughout means on both sides, dividing throughout by small v. So if you divide this first term, left hand side will become 1 by u. If you divide this right hand side first term, it will become 1 by f. Minus, if you divide this 1 by v, it will become 1 by v. Is it not? This negative term, you shift it to the left hand side. So we can write this 1 by u plus 1 by v. 1 by v is equal to 1 by f. So this is the required relation between, okay, this is the required relationship between the object distance u, image distance v, and the focal length f. So this equation 5, understand, this equation 5 only is called the mirror equation. And you must know that it is the same for convex mirror also. Whether it is concave mirror or convex mirror, the same equation only you will get. You practice as a homework, you try for a convex mirror. When you draw a convex mirror means what will happen? For a convex mirror, the focal length is positive, is it not? And the image formed may be on the right side, depending upon where the image is being formed. It is a virtual image. So image distance may be positive. But the final equation will be the same. Understand? I hope you must have understood how to derive this. Fine.